Hi, Algebra 1, and this is all about variables and expressions. So we have some vocabulary here that we're going to be going through, and we have a lot of words that we use often in Algebra 1, and so I want you to know the difference in what those words mean as we move through the course this year. So first of all, a variable is a letter or a symbol that represents a value. And obviously, since the root word of variable is to vary, the variable can change. It can be defined as something, we can solve it for something, but it can vary. That's a variable. A constant obviously is something that doesn't change. It is a value that does not change. And normally it's just a whole number. Next, we've got expressions. An expression is different from an equation. So an expression contains variables or constants and operational signs. These are all examples of expressions. 3 plus 4, 10 minus 2x. 6x squared minus 7x plus 1. 14a squared bc cubed. All of these are in expressions. Now, this first expression, it can be simplified, and we know that 3 plus 4 has the value of 7, but these other three cannot be simplified in any way. This is a two-term expression. It's called a binomial. This is a three-term expression, 1, 2, 3. It's called a trinomial. But this guy is a monomial. It only has one term, monomial. It only has one term. The terms are delineated by the operational signs, plus, minus, times, division. An expression may or may not be simplified, and it does not have an equal sign. Lots of times in class I'll say it does not have a verb. These are not set equal to anything, therefore they are simply expressions. So we have lots of words that we'll use when we're doing word problems, when we're talking about mathematics. And sometimes we need to translate between an algebraic expression and words. So let's take just a minute and let's write down some of the words that indicate addition. So obviously, add, or addition, or sum, or plus, or increased by. So those are all words or phrases that indicate addition. Oh, just thought of another good one. The total. Okay, those are all words that indicate addition. Words that indicate subtraction. Obviously, subtract. Subtracted from. Less than. Decreased by, an obvious one, minus, and then of course you can find a difference, and any time that you're taking the difference of two numbers you're going to be subtracting. Now, just a reminder that in Algebra 1 we're going to let x be x, and when we see a dot, we know that that is multiplication. Also meaning multiplication would be parentheses butted up against each other. But what are some words that indicate multiplication? Obviously, multiply or multiplied by. How about twice or doubled? Or here's a good phrase, increased by a factor of 5. Increased by a factor of 10. Now, increased by does mean addition, but when we say increased by a factor, it becomes multiplication. So that's something that's the same, and that's something that's a little bit different. Next, we've got the good old division sign. Now, lots of times we're going to use a big fat fraction bar. So we can say 10 divided by 5. That means exactly the same thing as 10 divided by 5. And lots of times in algebra class, we're only going to use the big fat fraction bar rather than the old school division sign. But what are some words that you're going to see? Well, obviously, divide or divided by. How about, let's see, we can take, obviously, quotient. A quotient is what you get when you divide two numbers. And let me loop back over here on multiplication. I forgot. When you multiply two things together, you get a product. So a product is multiplication. A quotient is division. So divide, divided by. Let's see. Trying to think, are there any more words for divide, divided by? We could take, we could maybe write a ratio. That's another word that does indicate division. Ratio is a synonym for fraction, and of course a fraction is indicating division. So those are all words or phrases that you sometimes need to translate between an algebraic expression and words. So, got 4 problems here. Let's rewrite these using words. And obviously, these can be done many, many ways, so we're just going to do a couple. So, we could say this is simply 9 plus a number r. Or we could say 9 increased by r. Or we could say the sum of 9 and r. So there's 3 ways to write 9 plus r. Okay, q minus 3. So when we're doing addition, order not so much important. But when we're doing subtraction, order is very, very important. So here we've got q minus 3. That's a very obvious one. We could change it to 3 less than q, because it's the 3 that's being taken away from the q. So order very important here, because when we say 3 less than q, we're indicating that q was there first. We could say the difference of q and 3. So 3 ways of writing that. Next, this one has multiplication as well as addition. And multiplication has to happen first because of order of operations. So we could say 2 times m added with 10. That's one way to say it. We could say double the variable and add 10. Another way to say it. Or we could say 10 more than twice m. 3 ways to say the same expression. And once again, these are all expressions. They're all expressions because they are not set equal to anything. They become an equation once we set something equal. So, lastly, and this has parentheses, which are indicating something that has to happen first. So I'm going to set off those parentheses with some words. So I'll say the sum of j and 6 divided by 10. when I say the sum of j and 6, that's what's indicating those parentheses. And those parentheses are indicating that they must happen first. So let's see, what is another way? We could say the ratio of the sum of j and 6 divided by, actually I don't want to say divided by. If I'm calling it a ratio, there's where I'm indicating division. The ratio of the sum of 6 and j and 10. There we go. So I don't need to say divided by, because once again, when I say the sum of j and 6, I'm saying that has to happen first, and when I say ratio, that is what is indicating the big fat fraction bar. So running out of room here, trying to think of another way. We could also say the quotient of the sum of j and 6 and 10. So that's another way we could say that, all using words. So sometimes an expression can be evaluated, and every time that you see this word evaluated, you need to get ready to do some substitution. We're going to be plugging in numbers whenever we see the word evaluate. So to evaluate, we'll use the substitution property and apply GEMS, which is the same thing as the order of operations. So to now simplify. So notice what we're doing here. We're given, or we're defining the values for x, y, and z. X is 10, y is 12, z is -2. So when we evaluate, we're going to be substituting in those numbers, then simplifying. I like to use parentheses when I evaluate. It just keeps everything nice and neat. So here goes, 2 times x, x is 10, plus y, y is 12, minus 3 times z, z is -2. So next we're going to use and follow the order of operations, grouping symbols, exponents, multiplication or division, subtraction or addition. We're going to follow that order of operations. So we do have some grouping symbols, but there's nothing to do inside of the grouping symbols, and that's what that G really represents. Next is E for exponents. There's no exponents here, so we're going to the M. M is multiplication. We're going to multiply here and there. So 2 times 10 is 20, and -3 times -2 is +6. Now, I did use parentheses here, but since there's really nothing in front, we can get them out of those parentheses. And now we've got straight addition all the way across. So 20 plus 12 is 32. 32 plus 6 is 38. We evaluated using the substituted values for the given variables, following order of operations. We always, always, always follow order of operations. Last problem, given A equals 14, B equals -6, and C equals 10. So we're going to use substitution here and plug them in. So A plus B. So 14 plus -6 squared minus 4 times C. Notice I'm using parentheses here for my substitution. So C is 10 all over 2 times A divided by C. Whoop, C is 10. Make a 10 out of that. Plus 2 times B. And yes, you can even use parentheses inside of parentheses. That's fine. Those are called nested grouping symbols. So now we're going to follow G, E, M, S, and this one has a whole lot going on. So the first is G. Do everything inside the grouping symbols according to order of operations. So right up here on the top, 14 plus -6. 14 plus -6 is the same thing as 14 minus 6, and that is 8. 8 squared is going to happen next. Minus 4 times 10 over 2 times 14 divided by. Now, we're going to go to the innermost grouping symbol first. And that's here. This is inside of parentheses. We've got more parentheses, so yes, we got to do this first. 2 times negative 6 is a negative 12. Now, I'm going to keep going. Normally, I only work down the page, but because we're recording here, I've got to work to the right one time. Nothing on the top is going to change because I'm still working in the G. So 8 squared minus 4 times 10, 2 times 14, divided by 10 plus negative 12. 10 plus negative 12 is negative 2. I'll keep it in parentheses. Next, we're going to the E. And our exponent, only one, is here. So we're going to evaluate the exponent next. That will be 8 squared, which is 64, minus 4 times 10 over 2 times 14 divided by negative 2. Okay, we did the G, we did the E, now we're going to the M. We're going to multiply or divide in the order that it comes from left to right. So 64 minus 4 times 10 is 40 over 2 times 14 divided by negative 2. The multiplication comes first from left to right. That's 28 divided by a negative 2. I'll keep that in parentheses. You can keep it or not. It doesn't make that much of a difference. So now we've got 64 minus 40. That is 24 over 28 divided by negative 2, which is negative 14. And then from here, let's just simplify this fraction. So 24 and 14 have a common factor of 2. So this is going to be 2 times 12 over 2 times negative 7. The 2's cancel. Our best simplified answer is 12 over negative 7. And yes, in Algebra 1, we love improper fractions simplified as best as possible. So that is everything we've got for this video. All about expressions.